Now this illustration deals with enclosing different size conductors in accordance with Table 5 and Table 4 to Chapter 9. Now notice the problem has a question: what size EMT is required to enclose 14 AWGs, 412 AWGs, and 410 AWGs, THWN, copper conductors. Now the first step, in Step 1, is to go to Table 5, Chapter 9, and obtain the cross-sectional area of each conductor based upon THWN copper conductors. So the number 14 is 0.0097. The number 12 is 0.0133. The number 10 is 0.0211 square inch area. Now, the area has to be multiplied by the number of conductors. So Step 2, we have 12 number 14, so when we take 0.0097 times 12, we come up with 0.1164. The number 12 there, we have 4 of those, so 0.0133 times 4 gives us a total of 0.0532. The number 10, we have 4, so we take the 0.0211 times 4, we come up with 0.0844. Now when we total the total cross-sectional area of all the conductors, we come up with 0.254 square inch area. Now we would go to our Table 4, and based upon over 2 conductors, 40% fill, we select the EMT to house them. We would come up then with 0.254 square inches, would require 0.346, which would be a 1-inch EMT that would be required, and that is the solution and the answer. So this illustration is showing if you want to make the calculation based upon the square inch area of each conductor times the number, this is the procedure that you would use if you just didn't make them all number 10 and then use the Annex C for EMT, and they'd all be number 10 conductors there. So you would see the number that you would have up there. You'd have 12, 4, and 4, so that'd be basically 20 conductors. Now, that would naturally produce a larger conduit, so many times electricians, where they have a number like this, they'll just go ahead and do this individual calculation and enclose the conductors in a raceway that is selected based upon the total square inch area as you see in the Step 2. So that's what this illustration is illustrating, enclosing different size conductors using Table 5, Chapter 9 to select the cross-sectional area of each conductor, and then using Table 4, Chapter 9, selecting the EMT to house the 0.254 that you see in Step 3.